Hello everyone, hope you're doing very well today. Welcome to this SEMactive online training session. My name is François Riendeau. I'm the Photogrammetric workflow specialist here at SEMactive, and I'm very happy to be your host for this highly interesting session about streamlining large photogrammetric projects with Correlator3D. So this will be a good occasion for me to show you all of the different options there is in the software in terms of workflow and processing. You're going to see that there is not just one way to process a project in Correlator3D, depending on the number of images that you have, the accuracy you want to reach, the configuration of your block or the type of area you're covering. You might want to use different strategies to process a project, and we're going to look at the different options in the software and how you can use them to get the most for your processing. So let's start right away. What are you going to learn today in the session? So first I'm going to review the different options there is in Correlator3D. We're going to talk a little more in depth about how to use scripts and batch processing. I'm going to show you how to split a Correlator3D project. So this is a question we have a lot of time. Let's say you have a big project and you want to split it in different parts to maybe process in parallel on different computer. So I'm going to show you how and when you can split the project in the workflow. And then we're going to look at real-world scenarios with different project types and configuration. And for each of them, we're going to discuss strategy and how we can process these type of project efficiently with the different options we offer in the software. And finally, I'm going to answer a question you may have at the end. So let's first discuss the different options that we have in Correlator3D to process a project. The first one, obviously the one that most people are using, is the graphical user interface. So you can process a project interactively in the interface and use all the modules, manually set your parameters, do a quality check on screen in the mapping view, and use the graphical interface to process a project. I'm not going too much in details about the interface because this is something we're covering in other sessions, and most people already know how you can use the software that way. But let's just say that in the graphical user interface, you can do different things. Obviously, you can do interactive processing. All of your process can be done manually, but you can also launch the automated workflow, which I will be talking a little bit more in a few minutes. And you can also run scripts from the graphical user interface. So let me just quickly show you where you can do this in the software. So let's say you are in the project, so you just have to go in File, and here you have the option to run script. And you have to be careful, though, when you're launching this. The software will warn you that it's going to exit the project you are currently in to run your script, and it won't necessarily load the result automatically in the software. You're going to have to load the result yourself in an empty project. So a second option in Correlator3D to process your project would be to use the automated workflow. The automated workflow is a little bit like the one-button automatic processing solution. This is something that can be good if you don't know too much about the workflow in Correlator3D and the different modules. That's a good way to start. But as you're going to see at the end when I'm going to talk about the different scenarios and type of projects, I will rarely recommend to use the automated workflow because when your projects start to be a little complex, you probably want to have more control and interact, and or either using script where it's a little more advanced in terms of what you can do. So the automated workflow can be a good way to start to quickly process your project, sometimes just to see everything is good. So there is different way to use it. So first of all, it's from the graphical user interface. A project must be created. And then you have different profiles that going to set parameters for different type of processing workflow. So you can select a profile or you can customize the parameters and the option yourself. And then when you process, the result will be automatically displayed in the project after the processing. Another thing that you can use the automated workflow for, which is very interesting, is you can use it to generate a script. So for example, you can set the different parameters of your workflow for the different module. And when you generate this, you check the option to generate the script. When you process, this is going to create a script which you can edit or customize or run, use this script as a base to start scripting. So just as an example how easy it is to do this. So you go to the automated workflow right here. The project must be created. So let's say you have imported some images as I just did here. And now you would be ready to process. So you would go into all of these modules, check for the parameters. Maybe you would like to change a few of them. For example, if you want to edit the resolution and enter something a custom value. And then you can process and the software will go automatically into all the module and will generate all the results. So you can go, you can do this, for example, during lunchtime and after you come back and all the results will be generated. Obviously, I recommend to do a quality check on your result after this process has completed. Even you can go back up to the aerial triangulation and be sure that your report has good residual. And then you can look at your elevation model and Mosaic. But as I was saying, you can just check the option here, generate a script. And if you click process, the software won't generate the result, but in place it will create a script like this that you will be able to edit. So I'm going to talk about the script and the syntax in a few minutes, so don't worry. But this is a good way to start, so you don't have to type all of these parameters in the script just by using the automated workflow, and with this option we'll create a script for you. And finally, a last option that we have in Correlator3D to process a project is to use script with the command line mode. So everything in the interface, so all that you have in the software, all the module, all the tools can be run using a script. So this makes a very powerful option for you if you want to highly automated your process and your workflow. All that you have in the software can be scripted, so you can really automate everything, even the small tools like change detection or the DEM inspection for checking the quality of your DEM. All of this can be automated with a script. It uses a simple syntax. I will explain a little bit how it works. All parameters and settings are available in the user manual, so I'm going to show you all of that. And the script can be run from the graphical user interface that I just did a few minutes ago. Can be also run with the command line, or it can be called by another batch or program, for example, that you will have to do with Python, or could be simply just a batch file from using DOS command. And I'm going to show you a couple of examples in a few minutes. To show you how it can be very interesting to use just the simple batch file of DOS command. But before, let me explain you the syntax of Correlator3D script. So if we go in the user manual, I think it's page 74, chapter 11, you will have explanation on how to use script mode. It's a very simple syntax. Each operation would start with a process name inside a quote like this. And then the necessary input-output parameters are defined, and they are placed inside these braces. So this is an example for DSM generation, where you specify the input dem, the input EO, resolution, and different parameters. And this script will be then saved as a text file and will be launched from a command prompt, where you will be calling the Correlator3D program with the name of your script like this. So you will be using the command prompt to type this command and launch your script. Then there's different switches and options that you can use. For example, if you want to generate a log file, or if you want to see the output progress percentage on the screen. If you go a couple of pages after this in the appendix, you will have the description of all the different modules that can be run in the script. And for each of them, all the parameters and the options that you can specify for running the script. So everything you see for aerial triangulation, you have all the possibility to adjust the EO and the camera in detail. And after that, you have the other DSM generation, DTM, and all the options that need to be specified, and if they are optional or you need to put them mandatory. So here I'm just reviewing a little bit how to build and run a script. So as I said, the script will be built first by mentioning the process, the module you want to run, and then all of the parameters that you will use for this process are specified inside the braces. And in the manual, you have all the information to know how to run the script. Now, one thing is important to mention is that there is maybe one missing link in the scripting, is that the project creation is not included. So the project must be created if you want to run the script, because in terms of software implementation, the project creation is a little bit different. We had a lot of demand from our customers to have something that could create project automatically as well, so that everything could be now automated, including the project creation. So now there is a program, Convert.io, that will let you create a project and that you can use to do the project creation and then run the script. So you need to use this Convert.io program that is located in the software installation folder. So if you go in Program File, Semi-Active Correlator3D, you will find a Convert.io program here. And this can be called from the command prompt. So if you want to know how to use Convert.io and what are the parameters, then you just have to type in the Convert.io like this with the complete path and do enter. And it will return you the help and telling you what are the parameters you need to use and how you have to use this command. So Convert.io requires a couple of things, because obviously creating a project, you will need a couple of inputs. So you need to have an image folder. You need to have an exterior orientation file that contains the position, the GPS position in a text file, and you need to have a camera file. The Convert.io actually will create a EIO file that is required by the aerial triangulation, which is usually the first module that you have in a script of Correlator3D. As I shown you, Convert.io is located in the semi-active installation folder, and you can just type in the command line in the command line prompt to have the help and know how to use it. So here there's an example where I'm showing you all the different options there is and what are they need for. So you need to specify the projection, your camera file, input image folder, unit, etc. So now that you have Convert.io and the script, you can use both of these tool or function or program to automate all the workflow and all the steps of processing in Correlator3D. So Convert.io will do the project creation, and then the script will run through the workflow to do all the processing. Now, one thing you might want to know is how you could loop the script on different projects. So let's say, for example, you have different missions, and you want to run all of these different projects with script, and how you can loop into these different missions to run all the script and the processing. So there's a way to do this. Quite easy to do is to use the dust command batch file, or you can also use Python, for example, if you want to create a program that will call the different Correlator3D script and the Convert.io. But here I would like to show you a quick example with the dust command, because I think this is something that is quite accessible. The dust command actually are included with Windows since the 90s, and thanks to them they have never removed the command prompt and the dust command from Windows, so you still have access to these commands that let you do a couple of interesting things, as for instance using the for command will allow you to loop on different folders. So here I have an example where I use the for command to loop on a folder path where there will be different mission, for example, and from this I will call a script. So what it will do actually, it will do so for every folder that are included in this location, do call this batch and run it on each folder that I have set in this variable. So this is quite easy to use, and I'm going to show you an example that I just did. So I have two batch files that I have created, and one of them is calling Correlator3D Convert.io to create a project, and then after that it's calling a script to run the processing, and after that it's just doing a copy of the resulting mosaic into a deliverable folder. So just to show you that with a batch file or with a program, you can do other things than just running Correlator3D. So you can also move folder around, create folder, and all of that. And if I show you in what I have here in my folder. So in the folder processing test, I have 3 subfolders that I name 1, 2, and 3. And for each of them, I have an image folder, an input EO file that I have the geotags of each images, and a camera file. So that are the input that are required for Convert.io to create a project. And I also have prepared a script that goes into all the different modules of Correlator3D, and that will do aerial triangulation, DSM generation, mosaic, and the ortho and the DTM. So everything will be created with this script. So I have to assume when I'm creating this script that the Correlator3D project is created. But that's not already done, because this is going to be done with the Convert.io first, and then once the project is created, the script will be run, and it will be used. You see different folder that I assume that are created. These will be created by Convert.io before the script is launched. But here, if we go up to this little script over there, what I actually do is that I'm setting a for command to loop on the folder that I are include inside processing and test. So what I'm doing is for every folder that are located into processing, test, and here I'm just adding that they need to start with a 0 because I don't want to loop on deliverables and temp folder. Then do call this other program with for every one of these folder. But here you can see that you can use the dust command to loop on different folders, launch Correlator3D script, call the Convert.io program, and then run the script after that. So let's now see how you can split a Correlator3D project. This is a question we have a lot of time. Obviously, people that have very large project will maybe want to split their project into different parts and will maybe use different licenses to process the different step on different computers. So there are different places in the workflow where you could split your project. So if you want to split before the aerial triangulation, then I think it will be more like a photogrammetric problem in some way, in the sense that what is important if you want to split before the aerial triangulation is you might want to consider to have common ground control points between your different blocks that you're going to split. This is for a question of if you want to keep a good geometric accuracy between the block. So you're going to use these common ground control points during the aerial triangulation on the first block, and you're going to use the same points to do the aerial triangulation of the other block. So this way you're going to ensure that you're going to have the good planimetric and vertical accuracy between your blocks. Maybe another way that you could do this is you could maybe do the aerial triangulation on the first block, generate a DSM and a Mosaic, and then use these DSM and Mosaic as a reference into the aerial triangulation of the second block. So when you're going to create the second project, you would use the output ortho or Mosaic and DSM as a ground reference in the aerial triangulation of the second block. So in Correlator3D, you have this option to import and use a reference when it's time to run the bundle adjustment and the aerial triangulation. So the software will tie this block onto the reference coming from the first block. So that would be another way where you could split into different aerial triangulation. I think here what you have to remember is the challenge is to ensure that if you split the aerial triangulation into different blocks, you have some way to ensure that you're going to have a good accuracy between all these different blocks. So in what situations should you split the aerial triangulation into different projects? I would say, to be honest, in Correlator3D, try most of the time to do the aerial triangulation into one block. The software is quite powerful to adjust a very big project to do the aerial triangulation on thousands of images without any problem. So I would recommend that if you have a very consistent block, continuous block, even it's very big, try to do the aerial triangulation into one single block. Depending on the configuration of your block, if you have, let's say, a very large body of water that is separating a part of, let's say, on the north and then on the south, and it's split in between by water, then maybe you could split this into two different blocks, because anyway, where there is the water, it's maybe not important that if the block will very accurate into the water to touch each other. So, however, you be sure to have ground control points on the land in between each block. So most of the time, I think that you should try to run the aerial triangulation into one single block in Correlator3D. Now, what would be maybe more common is to split the Correlator3D project after the aerial triangulation. The way to do this, there's maybe a couple of ways to do it, but one way should be that first you will run the aerial triangulation maybe of all your single block on one computer. And then when it's time to separate the blocks, so you want to send some part of the project on another computer, So what you can do is after the aerial triangulation, you can export the exterior orientation that has just been refined by the aerial triangulation and the camera parameters. You export this and you're going to use this on another computer to import and create a project. But what you can do is you can edit the exported EO and maybe remove the image that you're going to keep on this computer. So you just import maybe the sub part of the big project. So you edit your EO file that you have exported and you just keep the images that you want to import on this second computer. That might be a smaller area where you will process a DTM, ortho, and then you're going to, when you have the ortho that are generating, you're going to copy them back on the first computer where you will have run the other part of the project. So on this first computer, what you can do is disable the images that you have sent on the second computer. And so you will run DSM and DTM only on the part that you have kept on this computer. Then at the end, you're going to merge back all the ortho into a folder, and you will probably want to run the Mosaic into a single file, a single Mosaic with all the orthos that has been maybe generated from different computers. Now there's also another things that can be done from different computers, and it's the Mosaic editing. There is this one module in the Mosaic editing. It can be edited from different computers. This requires a floating license, and then you need to have a Correlator3D project that will be stored either on a server or on one computer. And you can access this project from different computers, and each user will have the possibility to select a block of the Mosaic and edit this specific block. So when a user will select a block, this block will turn red, and so the other user won't be able to select this block because it will already be in edition. So like this way you can edit a Mosaic. So let's say you have a very big project and there might be, it's maybe an urban area, and you see there's a lot of edition to do on the Mosaic. So you can do this from different computer with a floating license. Now it's time to talk about a real-world project scenario and see for each of them what would be the strategy now that we have reviewed all the options in the software, either using the graphical user interface or script. And now that we know how to split a project with large, if we have a very large project. So now let's take different scenarios, and for each of them, let's apply different strategy with the option of Correlator3D. So for each of these project scenario, I'm going to talk about our recommend workflow. We're going to discuss processing time, some things to consider, what would be the hardware required for this type of project, and also what are the resources that can process this type of project. So for the resources, this is just some kind of indication. You'll see that in some specific case, there might be some competences that we want to have in our project. So that's just what I wanted to give here in the resources. So let's start with a very easy single mission small UAV project. So let's say you have about maybe 50 images, a continuous block like this with parallel flight line. So this is a very easy project that you can run in the graphical interface of Correlator3D. And you can either use interactive processing or run this with the automated workflow. So because it's very fast, usually this will be run in maybe inside 1 hour or just a few hours. You will probably need only interaction if you want to measure ground control points, but all the rest can be run automatically. And quality control can be done just before delivering. So because it's very fast to run all of this, you can run all the processing and at the end do the quality control before you just deliver. as opposed to when we will talk about a very large project, you will see that I will recommend to do quality control after each step. But for a small project like this, you can just run the automated workflow, and then when you have all the results, you can do your quality control at the end. To run this, you will need only a small laptop or a PC with basic graphics card, not necessarily a lot of RAM, so 8 GB of RAM will be enough. And this can be run by a UAV pilot, a surveyor, or a GIS technician. Now let's talk maybe a little bit bigger project with UAV. So when projects tend to be larger on terms of the area you need to cover, with a UAV, it might require different missions. So you will need to fly this with different missions. So for the workflow, I would recommend actually to do the aerial triangulation interactively. Maybe you're gonna have ground control points. You want to be sure that this block, all the missions are tied properly together. You want to have a look on your residual. So I think at least the aerial triangulation and the project creation should be done interactively. And after that, maybe you can do the remaining step with the automated workflow or with scripts. In terms of processing times, obviously it depends on the amount of images, but we can say that maybe it's going to take 1 day or more to do all the processing. It's a little longer than just process 50 or 100 images. Here we're talking about project of the range of thousands of images and more. So things to consider is that you will have to create different camera groups for each mission. So this will help the aerial triangulation. And you have to have in mind that probably large output files will be generated. So maybe when it's going to time to create a mosaic, you probably want to tile your mosaic into different tiles. And also, you may want to ask yourself the question if what type of resolution you need for your DSM, because the DSM generation is one important process in terms of time in the workflow, and it can generate large files. If you go with too high resolution and you don't necessarily need that, you're gonna lose some time on the DSM generation. So ask yourself if you really need a dense elevation model. If it's just for an ortho or mosaic, you can easily go to 5 to 10 times the resolution of your input images, and this will save you a lot of time in the processing. Again, for the hardware, standard PC with a basic graphics card will be enough to run this type of project. So Correlator3D take advantages on the GPU. So even with thousands of images, you don't necessarily need to invest in a very expensive computer. As far as you have a supported graphics card with good specifications, it will be enough to run these type of projects. And again, for resources, the project like this usually will be run by a UAV pilot, a surveyor, or a GIS technician. Now here's something interesting in terms of processing workflow is that, let's say you want a setup, a continuous stream of UAV projects. So you have continuously new project to run, and you want to set up a pipeline where these projects will be run one after the other, and into some kind of processing chain. So now it will be the time to start to look at command line and script. So you will want to automate all of your processing so you can run these projects one after the other using the script of Correlator3D with a processing chain that would be entirely automated. So in terms of processing time, obviously here we're talking about continuous processing. Things to consider. Well, let's first, let me jump to the hardware, because this type of setup would be good maybe to run on either on the cloud, so on the AWS or Azure instance, or on a virtual machine that you have created on your server, and where you're gonna put all of your script, and that's where everything could be run automatically in a continuous way. So things to consider in that case is if you're going on the cloud, you might want to consider that there's data upload and download that will be required and that may take some bandwidth. So it's one thing to process continuously the data, but you also have to consider that you need to upload your data on your machine. And so that might require some system configuration at the beginning. So it's not necessarily just installing the software and you will be ready to process. You might want also to set up some security and user access, things like that on the virtual machine. So some development will be required at the beginning. So to create all of your script and doing all the development of the automation of your processing chain. But once all of this is set up, that could be a very powerful processing chain and will be very efficient to run continuously your process. One thing to consider as well is your quality control should be probably done on a different machine. So you will have the software running continuously on the cloud to process and generate your outputs. And then you might want to download this result and put them on another machine and do the quality check. So even if all is automated, it's very important to do the quality control on the results. So you might want to dedicate one machine and a resource to do this after each job is completed. So in terms of resources, because of all these system requirements in terms of configuration and development, you might want to have the help of a system engineer and even a programmer. But for running the project and doing the quality check, a GIS specialist and technician will be able to do this. So scenario number 4, that would be the type of situation where you have a project, but a project is kind of discontinuous areas in space. So let's say you have flown these different areas, and they are you have multiple discontinuous areas like this, and you ask yourself, can I do this in one single Correlator3D project, or I need to create a different project for all of these small missions? So the answer to this is yes, maybe in some situation you should create only one project, and that would be the case if your area are not too far from each other, so you can easily put them all in the same project, and that should not pose any problem to Correlator3D to process everything. And even you see at the Mosaic step, the software will understand that these projects are not continuous, and it's going to create these different blocks, so you just gonna have to edit and export the Mosaic for each of these blocks. However, if the projects are far away from each other, that might be a little more difficult for the software, because some processing like the DEM generation will be done in continuous mode, and that may create a very big elevation model. So in some case, if your mission are too far from each other, we recommend to create different projects for each of them. However, what you can do if you have all these different projects created is you can use the looping function that I've just showing you a little earlier in this session, and create a script for each of these projects and loop with the command prompt, so the script are launched for each mission one after the other. So in terms of workflow, you could use batch processing of script on the multiple flights, and obviously you will use the convert.io function to automatically create all of these projects. So only what you would need to have is the input images with the associated exterior orientation parameters and camera into different folders, and then you can use batches to process these different projects one after the other, so you'll be looping on all the folders for the different mission. Processing time, that would depend on the scope of the project. If you just have a couple of small projects like this, that may take just a few hours, and it can go to a couple of days if you have a lot of them. The thing to consider could be run maybe into one single Correlator3D project if the area are close to each other. Then if not, we will recommend to create different Correlator3D project. Standard computer again can run this with basic setup of a memory and graphics card, and could be run by a GIS technician or a specialist. Finally, the real-world project number 5 is, now that we have a look at all these different projects, now we can discuss the processing of a very big project, one of those big 10,000 and more images of project. So when it's time to process or to manage a large project like this, there's different things to consider that you won't have in mind if you process a small 100 images project. Now we need to talk about project management and resources and having things split on different computers. And so you will have to planify your project, to plan your project at the beginning and try to organize the work into split it into different resources. So project management is very important for that type of project. So in terms of workflow, if possible, I would say try to do the aerial triangulation in one single Correlator3D project. So especially if your block is very continuous, like a big block like this, and even if you have 15, 20,000 images, you can run the aerial triangulation into one single block. That will be more easy for you to manage all the accuracy of your block. Maybe it's going to take some time to measure all your ground control points, but I think you won't have to worry about having different blocks and ensure that they are fitting with each other. So that's what I would recommend, is doing only one project for the aerial triangulation. Then after that, obviously, you want probably to split the remaining process onto different machines. So you will split the project into different sub-area, and let's say you have 4 resources and 4 licenses, then each of them will be able to work on a part of this project, and this will advance faster for your timeline. Obviously, I think you will take advantage of all the options in Correlator3D for a project like this. So you're going to certainly use interactive manual editing to quality check your products, your outputs. You will want to maybe do some DEM editing, Mosaic editing, and also you'll probably use some batch processing. Probably you will just process some specific module, and then you will do quality check after the processing, because here it will be very important to do quality check after each step of the workflow, especially after the aerial triangulation. So in terms of processing time, this is a project that will go for many days. So splitting the project into different area will allow you to deliver sub-area maybe faster and quickly. So sometimes customer wants to have deliver very quickly to see some results, but obviously if you try to go into all the project, it will be too long. So the solution is to create a sub-area and generate all the results on this small area, and then you can deliver some result to your customer. So to ensure that everything is satisfying and meeting the specifications. So things to consider in a project like this. Obviously, disk space will be a matter to have in mind, because for a big project, you're going to generate a lot of data. And project management will be very important, so you'll need to plan your project carefully. You will want to maximize overnight and weekend processing. So that's where you may be going to take advantage of the batch processing. And you're going to take particular attention to the aerial triangulation result. For a project like this that may go for weeks, you want to be sure that the aerial triangulation is good, because you don't want to, for example, being at the Mosaic stage and now you just realize that there's a problem in the accuracy in some part of your project, and that's because you have one ground control point that was not good. And now you have to go back to the aerial triangulation and restart all the processing. You can lose a lot of time if you are not careful with the aerial triangulation results. So for this reason, I would probably give the aerial triangulation report to a certified photogrammetrist, and so you could look at this and be sure that it's meeting all the specification. In terms of hardware, well, maybe now we will talk about something a little more powerful than for the other projects. So you might want to have a PC workstation, and probably maybe you're going to use multiple licenses, maybe a higher-end graphics card like a 1080, and certainly SSD drive. This will maximize all the processing speed to get some more faster result. In terms of resources, you need a project manager to plan all the project and do all the management, GIS specialist and technician, and a certified photogrammetrist to ensure that the aerial triangulation process is done properly. So that's all for now. I hope this was interesting for you. If you have any more questions, you can send us an email. I'll be happy to send you either any file I use in this session as demo file, especially the batch file that I did. Just send me an email. I'll be happy to send you. So thank you for attending. I hope I'm going to see you in our next session. So have a good day. Bye-bye.